In the last about a few different elements and their what their shells look like, and we had a table set up here resembling the periodic table. We have hydrogen, we have helium, and then in the second row we had lithium and beryllium, and then down here we had boron, carbon, nitrogen, oxygen, fluorine, and neon. And we remember in this very first row, or this first period, we had a max of 2 electrons. Hydrogen had 1 electron, and helium had 2 electrons in this shell. And this was the first shell. And then this next row has the second shell, and then you have a third shell and a fourth shell, and so on, going down the periodic table through the periods. By the way, these are the periods. And here we remember that all of these electrons, if we count here, we have 8 elements. All of these elements are trying to get 8 electrons. So remember, lithium had 1 electron in this shell, beryllium had 2 electrons in this shell. And remember, this number is just talking about this shell. So overall, lithium, we remember, has 3 electrons, but in this shell specifically, lithium only has 1. And as we go down, we can see eventually we get to neon, which has 8 electrons. And all of these elements from the second period and down are all trying to get 8 electrons. And I'm going to write the second row here, and we're going to look at just a couple more examples of the pairing up between these different elements here. So let's look at, let's look at, let's see, we can do aluminum and phosphorus. Okay, aluminum and phosphorus. Alright, so here we have aluminum, and over here we have phosphorus. And again, we're going to draw the shells out, and I'm just going to draw the third shell, because we know that there's 2 more shells that are going to be inside of here, but at this point we know that these other shells exist, so I'm not going to draw every single shell. If you want to see what that would look like, you can watch the previous video. But this is the third shell, so I'll even write a 3 here, so we know that this is the third shell. And in the third shell of the phosphorus, how many electrons are we going to have? We're going to have 1, 2, 3, 4, 5 electrons in this third shell. And in the aluminum, how many electrons are we going to have? Well, if we count down, we're going to have 3. Now the phosphorus, remember, they're both trying to get 8 electrons. So the phosphorus is closer to the 8 electrons. So the phosphorus is going, when these 2 atoms get together, the phosphorus is going to hog most of the electrons from the aluminum because it's closer to the 8. And the aluminum doesn't really care as much about giving up the electrons. So these 2 elements, this is a huge simplification just for just to get the concept down. These 2 elements typically are going to have a little bit more reasons as to a little more complications into their bonding, but just for the example of this video, just to show you that these 2 elements, what the general bonding would look like. So essentially you would have an aluminum atom that's losing 3 electrons. So each one of these electrons being gone is going to generate a positive charge. So the aluminum, let me move down a little bit. The aluminum is going to have a +3 charge, or 3 plus charge is the way that they would indicate that. And the phosphorus is getting 3 electrons, and the electrons have a negative charge. So the phosphorus is going to have a 3 minus charge. Okay, so we can, based on what we know through our couple examples that we've done, we can see that lithium, let me take this up, get this out of the way. Lithium is always going to be able to give up that 1 electron that it has in its outermost shell. And by the way, these electrons in the outermost shell are known as the valence electrons. So these electrons in the outermost shell are the valence electrons. So lithium is going to have a plus charge because it has one electron in its outermost shell, and it's very willing to give that electron up. The beryllium is going to have a 2 plus, boron 3 plus, carbon is going to have 4. So I mean, you can look at it either way, but for carbon right now, we're just going to say that this is just going to be kind of like a neutral charge. For now, we're just going to say that, and we'll get into greater detail as to why that is later. The nitrogen is going to have a 3 minus, the oxygen is going to have a 2 minus, the fluorine is going to have a minus, and the neon, again, is going to be just neutral because it has 8 electrons already. It doesn't need any more electrons. So remember that these are negative, these 3 are negative, because they will take the electrons, because they're closer to 8. These 3 are positive because they will give up the electron. And by knowing this, we can literally just go down the row, and each one of the elements underneath is going to have the same bonding principles as the elements in the previous period. Okay, so if I gave you an element and I said, for example, let's say we have gallium. Let's say we have gallium. And gallium, if you don't know where that's at, that's in the looks like the 4th row. And gallium, I can go up the row, and if I go above gallium, I see that aluminum is the element above that, and boron is the element above that. And I know that aluminum and boron, well, you can even just, if you just know boron, it's fine. Aluminum and boron have 3 plus charges. So gallium must have a 3 plus charge. And this is the gallium ion, and this is what happened to gallium after an element like nitrogen, for example. An element like nitrogen would come by and pick up 3 of its electrons and leave it without 3 of electrons in the outermost shell. Okay, so then gallium would be a 3 plus. So if you wanted to know what an element's some people call it oxidation state, or their ion charge, that is one really easy way to formulate the ion charge. So if I asked you how many protons, neutrons, and electrons were in, let's say, fluorine, how many protons, neutrons, and electrons were in fluorine? Well, we know that the number of protons in a fluorine atom is 9, because it's the 9th element, and the number of neutrons in the fluorine, and by the way, this is fluorine 19, which is your standard fluorine. The number of neutrons would be 10, because 9 minus 19 is 10, and the number of electrons, the electrons would balance the charge, so it would be 9. Now if I asked you how many protons, neutrons, and electrons were in fluorine minus the ion form of it, now everything would be the same except the electrons. The electrons would now have, and you would have an extra electron giving you a negative charge, so you would actually have 10 electrons in the fluorine minus. If I were to ask you how many protons, neutrons, and electrons were in aluminum 3 plus, protons is just the atomic number, so protons would be 13, and the average atomic mass unit of aluminum is 27. So if I take 27 minus 13, I get 14 neutrons, and I have a positive 3 charge here. So that means that I'm going to take the proton number, and I have 3 more protons than electrons. That's basically what that's saying. So if I have 3 more protons than electrons, let me do that again. I have 3 more protons than electrons, so I'm going to subtract 3 from here, and I get 10 electrons. And this is the part that can throw people off sometimes, is because this is a plus sign, so sometimes you're like, oh, I might have to add these 2. But remember what this is saying. This is saying that you've given up 3 electrons. You've lost 3 electrons. That's why you would have a positive charge. A negative charge would mean that you've gained electrons. Okay? And there is a word for this, and it's okay if you don't understand this right now, but oxidation and reduction are kind of the fancy words sometimes that are used to describe these reactions or these charges. And the way that I remember it is, you can remember oil rig. So oxidation is a loss of electrons, whereas reduction reactions is a gain in electrons. And you have your oxidation and your reduction reaction. So this is kind of how a lot of people remember this. And so Al3 plus must have undergone a oxidation reaction to get it to be a 3 plus ion. So that's the basis of ions. I'm going to put one last example up that I want you to try, and maybe pause the video. And we're going to say that we have this nickel 62 plus. We're going to have this isotope slash ion, and I want you to see how many, and see if you can figure out how many protons, neutrons, and electrons that it has. So hopefully you paused the video and took a look at this. So remember that nickel is the 28th element, so its number of protons is going to be 28, because remember, this is the identity of the atom. Now we know that the mass of nickel here is 60, so that we know that there must be 32 neutrons in this nickel isotope. But also don't forget that it has a +2 charge here. So normally it would if there was no charge here, then it would just be 28 electrons to balance the charge. But we have 2 more protons than electrons. That's why we have a positive charge. So we would have 26 electrons. So hopefully you got that right. If not, I would encourage you to go online and do some practice problems before we move any further. But in the next video, we're going to begin focusing a little bit more on electrons. I'm going to skip bonding right now, and we are going to move to the concept of the energy in the electron, and then we will transition back to bonding and talk a little bit about that.